iron operates at 230 volts AC. The power rating of the iron is 1750 watts. A. Calculate the current in the iron when it is operating. The power rating of our iron is 1750 watts. This means our power supply is sending 1750 joules to our iron every single second, and our iron is changing that energy into heat energy. Now, if we know the current in our iron, and that's the coulombs per second, and we know the energy these charges have, this is joules per coulomb, and we remember the coulombs per second is amps and joules per coulomb is volts. Multiply joules per coulomb and coulombs per second together, we get joules per second, and that is the units of power. So our formula here will be power is equal to current times voltage. Insert the values and we get our current. Iron is switched on. It takes 72 seconds for the sole plate to reach the correct temperature. During this time, 126,000 joules of energy is transferred to the sole plate. The sole plate is made from aluminium. The mass of the sole plate is 0.650 kilograms. The initial temperature of the sole plate is 22 degrees C. Determine the maximum temperature reached by the sole plate. Now, to understand fully how to do this question, we have to understand what's meant by the specific heat capacity of a substance. Now, to understand that fully, it's a good idea to look again to see how we determine that. So I've got a wee animation for you here with a wee bit of background to help us understand what's meant by the specific heat capacity. If you wish to understand what's meant by the specific heat capacity for a solid, it's a good idea to understand how we determined it for a solid in the first place. Here we can see we have got the mains connected to a power supply that's currently off, and there's the rest of the apparatus that we need. You can see the joule meter. That's measuring the energy coming from the power supply before it gets to the 50 watt heater. 50 watt heater is providing the kilogram of solid with 50 joules of heat energy every single second. There's a thermometer measuring the temperature rise, and the orange and red background represents the insulation. And we can see we've got a temperature scale on the right. The initial temperature is 19 degrees, and the final temperature when we stop timing will be 20 degrees. And this is where the specific comes in, because we're specifically speaking about 1 kilogram of a solid rising by specifically 1 degree Celsius. Now if I switch this on, the timer will time every 1 second, the joule meter will go up 50 joules in 1 second, and the temperature will rise accordingly. Let's see how this goes. There's a temperature rising on the right, and after the 10 seconds is up, we can see 500 joules has been supplied. We would expect that because it's 50 joules per second. After 10 seconds that's going to be 500. Meanwhile, the temperature has risen by 1 degree C. So what's our specific heat capacity of our solid then? Well, if it's taken 500 joules of energy to raise 1 kilogram of the solid by 1 degree C, we say the specific heat capacity of our solid is 500 joules per kilogram per degree C. And if you look at your data sheet, that corresponds to glass. So we're asked to find the final temperature of our iron. So what have you been told? Well, we've been told the initial temperature is 22 degrees C. We've been told it's been supplied with 126,000 joules of energy. We're told it's aluminium, and from the table we can see that the specific heat capacity of aluminium is 902 joules per kilogram per degree C. So if we use the AH equals Cm delta T, put our values in, we can solve it for delta T. But remember, delta T is not the final temperature. Delta T is this change in temperature. So we have to add the initial temperature to this change in temperature to get the final temperature. Now, notice as well, you're also told the heater is on for 72 seconds. Now that is a red herring because you're also told the amount of energy that's being supplied. So that could confuse people. But the more you understand these things, the less likely you are to be confused with things like that. (8b) Part 2. Explain why the maximum temperature reached by the sole plate will be less than that calculated in B Part 1.